All right, let's try this one. It's actually cooler outside. We should just open the windows. Oh no, we're in the basement. That's right. All right, let's try that one. That's where they put the most important people, though, by the way. It's in the basement. All right, so it's a sign of honor. All right, so is the answer going to be positive or negative on this one? Positive. Right, 2 negatives make positive. 18 divided by 3? 6. You don't need to put the plus sign, just regular 6 is fine. Just making sure we know the rules. Same rules for multiplying and dividing. All right. Do y'all have your calculator? What is minus 6 divided by 0? Which calculator have to say? Yeah, don't do it too many times. You break your calculator. No, I'm kidding. It's just air, right? It's just an air. Now, technically, we write undefined. Undefined. That's the answer. Yeah, you can't have 0 in the bottom of a fraction. Why not?
6 pieces of nothing is nothing.
Well, so why wouldn't the answer be 0 then? 6 pieces of nothing would be nothing, so that should be nothing, 0. Why is this undefined thing? Why don't we just say 0?
You have nothing to divide into, right?
Yeah. What if I said, hey, well, think about what a fraction really is. What if you said, okay, I've got, how could I do it? I've got 10 pieces of candy, 10 candies, and I'm going to divide it among 2 people. How many candies will each person get? 5 candies each, right? 10 candies divided among 2 people. So I'm just trying to make it real. Okay, so what would that mean if you put 0 on the top? What if I said you got 0 candies, I'm going to divide that among 2 people. How much candies does each person get?
0.
Yeah, 0. I mean, 0 candies each, right? That'd just be 0. Not undefined. That would just be 0. If 0 was in the top, that would just be 0, right? Now, what if you put it in the bottom? So I'm going to put it like this, right? So it's candies on the top, people on the bottom. So 2 candies divided among 0 people equals what? So if you take 2 candies, right? So over here, see the difference here? Here, 0's in the top. I'm trying to explain what 0 in the bottom means. It means undefined. It means craziness. I'm going to try to show you by a real life example. It's not 0. There's a difference between 0 and wacko. That's the 2 things we're distinguishing. Undefined means that's crazy. Doesn't mean 0. Let me show you why. Let's be real. 0 candies. We already did this one. 0 on the top. That's just 0. That's not wacko. I mean, it's a little weird, but it's answerable. It's 0. If you have no candy and you break it among 2 people, they got no candy. It's a little weird, but yeah, okay, no candy. But what is this mean? 2 candies, break it up among no people.
Still have 2 candies, all right.
Well, who has 2 candies? How many people we have?
But there's still 2 candies. Like.
Yeah, but remember what we're supposed to do is candies each. Candies each. So each person, that means each person, right? So how many candies for each person, right? Each of these means each person. That's what we were doing in all these problems, right? When we were saying 10 candies among 2 people, there's 5 candies for each of those persons, right? Not of other persons, but of these people, right? And if you have no candies for 2 people, then no candy for each of these 2 people. So, continuing with real life, 2 candies, no people, divided among no people. Yes, you've got 2 candies, but you don't have 2 candies for each person. How many candies do you have for each person? Do you have 0? Say, well, 0 candies for each person. What do you mean each person? There's no people. It's not 0. That would imply there's people there. There's people there having no candy in their hand. There's no people there. So, in the end, do you see this is just wacko? You can't divide by 0. That makes no sense. In all of math, 0 on the bottom of a fraction, it's not 0. That's what I'm trying to distinguish. That's a mistake people think, oh, they go, it's 0. No. It's crazy. It's undefined. That's why we say it. So when we say undefined, we mean that it has no definition in the real world. That can't happen in the real world. That's what we're saying. So you have to remember, 0 underneath, here's my little memory device, is undefined. Just remember under. 0 underneath is undefined. 0 in the top, that's okay, that's just 0. 0 in the top is just 0. 0 underneath is wacko, it's undefined. You can't divide by 0. How do you take 2 candies and break it up among no people? What do? You can't do that.
Room on their own.
It's just for them, huh? All right, so 0. So this is just dividing. This won't be a problem. You can do this on your calculators too. I'll show you by hand. Probably you remember. What do you do when you divide 2 fractions? Yeah, you remember that? And which one do we flip? It's got to be the second one. Yeah, you have to flip the one on the right and make it a multiplication. This becomes times. Whoop, I didn't flip it. Like that. So it's often called invert and multiply because you flip it, you flip the one on the right, and you change from dividing to multiply. So really, dividing is upside down multiplication. That's what it really is.
Or we use that keep, change, flip to,
What's that?
you can use the keep, change, and then flip.
Never heard of that. Keep, change, and flip?
Yeah, you keep the first number, change the second one, and then flip.
Oh, nice, yeah. So you keep this one, change this one, flip this one. Yeah, I like that. Keep, change, flip. Jim is Nader or somebody? Or
Jim, here.
Oh, Jim Yang.
Yeah.
Okay, that's good saying. Never heard of it. All right, keep, change, flip. There we go. We keep the first one, change the middle one, flip the one on the right. Good. Now we're to this level. How do we multiply 2 fractions? Do I have to make the bottoms the same?
No.
No. When do I do that?
When adding or subtracting.
That's adding, subtracting. Remember, adding, subtracting is always harder. Always harder. That's when you got to do that. I don't have to do that. I can just go straight across the top, right? Top, top, bottom, bottom. Or you could cross cancel if you know about that. That would actually be a little more convenient. Yeah, so let's do that actually, huh? 3 goes into 6. 2 times.
Now, when the negative is in front of, like in the middle, how it is,
Yeah?
both of the numbers, that means both of them are negative?
Good question. No, actually, all we got to do with the negative is, yeah, good, really good question. Let me finish the problem and let me go back to that question. So what do we have left on the top? Just a 5. What do we have on the bottom? 8 times 2, 16, right? Because the 3 and the 6 are gone. They're no longer there. So all we have on the top is a 5. All we have on the bottom is 2 times 8, which is 16, and it's negative because we had negative. Yeah, now, good question about the negative. What do you do when that negative is in the front middle like that, like 3/8 or whatever? How do you know logically, remember, who's on the throne of math, not Mr. Heron, but truth, right? Think about truth with me. Why would it not be that? Why is that not true? Negative in the front middle is really negative on both. No, cannot be. Says truth, no. What truth?
Because that'd be like probably 2 negative, or like.
Yeah. And what are 2 negatives?
Positive.
Positive. That can't be the same as negative. 2 negatives would be positive, not negative. So we know that's not true. By the truth we already know, right? So what does it mean then? It just means 1 negative. You can put it in the bottom only if you like. You can put it in the top only if you like. You can leave it in the front only if you like. But don't put 2 of them because that's positive, really. Does that make sense? So really good question. Glad we talked about that. When you have 1 negative on a fraction, it doesn't matter where it's at, right? 1 negative on a fraction, it's front, top, or bottom. Any of those is fine. That make sense? This is where I feel like I need to do Wizard of Oz. You know what I mean, right? Ignore the lady in the front. Pay attention to the math lecture. No, I'm kidding. It's okay. We'll let Katrina write her stuff up there. Katrina, you're the tutor for DSPS, right?
Me.
That's what I thought. And your hours are going on the board. Negatives there. Are we all good with all that? All right, we're good. So 1 negative is just negative, wherever it's at. So what was our final answer to that question? This was just all side stuff over here. Here's our answer. -5/16. Let's try another one. What does quotient mean? Divide, yeah, we're in the divide chapter, it makes sense. Quotient means divide. So when they say quotient of something, they mean divide. So quotient of 45 and 15 means the dividing of 45 and 15. And the first one listed goes on top. So quotient of 45 and 15 means whatever the dividing of 45 and 15 is, increased by 12. What do you think I do with increased by 12? Yeah, totally. Add 12. You can put the 12 in the front or the back. It doesn't really matter. Just got to add 12 somewhere. All right, then you can use your calculator. If you happen to know this one off the top of your head, it's 3. And so 15, and we're done. Oh, you know what it is? At first, they want you to write the phrase. It's one of those where they want you to write it, and then they want the answer. It's like a two-part question, you know, where they want you to write out the phrase and then solve it after that. Good on that. So quotient means divide. That one. Okay. So try that one. So the quotient of minus 60 and 12, so that's the dividing. Subtracted from, remember what those, probably have that on the test today, here in half an hour. Subtracted from, what did we learn about what that means? Swap them, right? That's a hard one. See if you can do that one. There's a lot of tricks in that one. That would be an impressive one if you can get that one right. That one's got a lot of tricks. A lot of little traps are laid. Anybody got an answer? What is it? Good job. -2. -2. Yeah. See if you can get -2. You're doing very well if you can get -2. Okay, so subtracted from means this goes over here. And this goes over there, right? And we put a minus in the middle. Good so far. Is that making sense? Subtracted from means subtracted at the back, doesn't it? Right? Just following me on that one? Is that making sense? Right, that's what the word subtracted from means. Just think about simple numbers. If I said 7 subtracted from 10, you know that 7 goes in the back, huh? Right? I'm just showing you again that the words, the English words subtracted from, mean that thing goes in the back. 7 subtracted from 10, the 7 would go in the back, wouldn't it? So, that's what the word subtracted from means. So when they say blah, 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 this quotient subtracted from, we go, oh, well, that thing goes in the back. Put it in the back. Okay, and then we have the minus. That's because of the subtracted word. And then we have the 2 minuses that are given to us in the problem. Got to keep all those straight. All right, here we go. So divide this in your calculator, -7. Minus. Divide this in your calculator, -5, right?
Are you doing that for simplicity's sake? Because, how can I say this? You wouldn't try and find a common denominator and then subtract them?
Oh, yeah, no. Way easier to, yeah, I mean, you could do that. That'd be so much harder.
Okay.
Yeah, no, just divide them first. They're nice, clean, whole numbers. Yeah, no, that'd be a hard one there, Alex. That'd be tough. It worked, though. I mean, if you carried all that through faithfully. All right, so now what do we do with these 2 negatives that are right up against each other, head to head, as we say, no number in the middle? Positive, huh? So that'd be -7 plus 5, -2. That's a tricky one.
I did it without the fraction part.
Did it without the fraction part? What's I mean, how'd you do without the fraction part?
I just divided 60 and 12, and then, well, I did it on my calculator.
Yeah, no, that's fine. Yeah.
I did it separately, so I did.
You just got right to the minus.
Divided by 12.
Yeah.
Is -5, and then the 56 divided by -8 is -7.
Yeah.
And then I just did.
Put the minus in the middle, and yeah, no, that's great. That's great. You basically did what I did, except you just didn't write down the first fractions. You just jumped right to this line. Yeah, that's fine.
Yeah, I followed, I did the least common denominator thing.
Oh, yeah. No, yeah, I mean, yeah, if they're divisible, if you can divide, when you got a fraction like 56 over 8, just see if it's clean. Just go 56 divided by 8, go, that's just a 7. Yeah, that'll save you some work.
Where'd you get the plus?
The two minuses,
Oh,
right here, head to head, no number in the middle. Always make a plus. Good. Yeah, so that's on today's test, not the fraction part. They wouldn't give you fractions because that's the new stuff. But they would give you blah, 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 subtracted from blah, blah, blah. And you got to remember to swap the orders, probably on today's test. I don't exactly remember. But it certainly was on the practice exam yesterday, right? Subtracted from, and then the double negatives head to head with no number become plus. So make sure you're on your game here in half an hour for that. Okay. Parachutist descends 117 feet in 13 seconds. Use a signed number to find the average rate at which her position is changing. What do they want me to do? Yeah. See, they want feet per second. So they want 117 feet in 13 seconds. And they want it, when you're going down, they want it negative. Negative is down, right? Down is negative. So I'm hoping that's clean on the calculator. Is it? 9? Is it 9?
It's negative.
Yeah.
Oh, wait, no, I'm thinking of this one.
You had a different one? Yeah.
Yeah.
-9, right? -9 on that one.
I was doing the homework thing.
Right. Is that good? And they want negative because it's down. That's what they mean by signed. Negative because it's going down. So why did I know to divide? Because look at the units. Feet per second. Feet over seconds. So I put feet over seconds. That's how I survived physics, by watching the units. I used to not like units before then. They used to kind of annoy me. But then units became my friends in physics. I would look at the answer and go, oh, they want feet over seconds. Okay, I don't know what's going on in this crazy word problem, but I got feet and I got seconds, and that says feet over seconds, so I'll put feet over seconds. And a lot of times that worked out. Units were a help to me. Sometimes they can help you. They sort of tell you what to do. All right. Okay, try that one. Feel free to use a calculator. So they're testing the order of operations, aren't they? So the main thing to remember, what's the main thing to remember about the order of operations?
Negative, subtracting, or less.
That's it. Rachel, that makes me happy. I'm not always doing the Charlie Brown wah 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 voice up here. You guys are hearing some of what I'm saying. Good. Adding, subtracting is last. Exactly. Adding, subtracting is last. So that means don't do this subtraction. Start with the multiplication, huh? 6 times 9, you calculate 54. Then subtract last, 5. Good? Adding, subtract. So remember that today's test where I have some order of operations. Adding, subtracting is last, right? In the whole PEMDAS, adding, subtracting is last. Good? All right. Okay, so those straight bars, remember, are absolute value bars, right? Yeah, so first you have to, don't change any signs right now. First, work out the problems inside the absolute values. And when you're all done, the absolute values make them positive, don't they? So 6 times minus 8. So see what I'm doing in there? So I did those inner parentheses, right? 2 minus 10 is negative 8. Everybody good with what's going on? So I subtracted in here. 2 minus 10 is negative 8. And 4 squared is 16. Do the powers in the parentheses first, huh? Remember all that? And then this multiplies to be minus 48. This is what? So this is 96 minus 104. Good to there so far? Now you got to finish the problems in here before you, but don't change the sign right now. Finish problem. What is that? Minus 8. So be good to there. So I finished both the absolute value insides. Now, make them positive, right? That's what absolute values do after the problem's finished. I keep emphasizing the after, right? Because you got to do that first. So Alex, you were talking about yesterday on the practice test, right?
Yeah.
So it's easy to get turned around on that, right? Because you're just thinking absolute value changes signs, but it's at the end. Absolute value changes signs at the end, when you're all done with the problem. Well, not up here, right? But all the way down. Now that both of them are done, now make it positive, right? That's what absolute values do. At the very end, make it positive. So this will become a positive 48, right? It'll get rid of that minus sign, and it'll get rid of that minus sign, positive 8. But the one in the middle is still there, because he was not between two absolute value bars. He's still there. Just the other two get canceled out, right? And then the absolute values vanish. They do their job, make it positive, then they vanish. And 48 minus 8, 40. Good on that. We'll do that on today's test. Questions? As well. All right. Okay, try that one. I'll write it a little bigger up here. What's in the middle between these two absolute values? Multiplication. Yeah. So 29 minus 32. So do the, remember adding, subtracting is the last, huh? So I do this multiplication first, and this power, right? Do them first, and now subtract, what's that, minus 3. And this is something I don't know, 60 minus
Minus 84.
84, thank you. Good to there so far?
That's not a division.
I was gonna say that's not
Yeah,
division,
I did
it's
ask
division
division.
between
Oh, maybe it is.
power and 5.
No. Well, yeah, it looks like division. You're right. You're right. I'm wrong. Sorry. Yep. See my old eyes. Yeah. So forget that. Let's go back and try again. Thank you. You could see that, huh? Or you see it on your own thing or whatever?
Yeah, I can't see it. They need a new sign for division for old people.
I know. For you and me, we do.
Make the circles bigger on the top of the one.
Yeah, right.
Where
Oops, this should be 100, huh?
it's barely noticeable.
It is. Thank you. Okay, yeah. So then we got to do that division, huh? Before we do adding, subtracting, we've got to do that division. So take it from there, now that we know the real question. So that's a divide there, actually. I couldn't tell. What's that, 20? 100 divided by 5? It's 20. And then it's minus 9. Good to there. So we finished both absolute values. And what do absolute values do at the end? Make it positive and vanish. Right? So you're going to cancel that minus, cancel minus. It'll just become 3 times 9, 27. Positive, right? Is that good? You able to do that? With the greatest of ease? Maybe not the greatest of ease, but you able to do that? Questions I can answer on that? All right, so a lot of steps. The main thing, adding, subtracting last. Adding. Okay. That's my job.
This is on next week's test though?
Yes, next week's test. That's right. All right. Yeah, it's not on today's test.
Give me a week to go over it.
That's right. Okay, so try that one. Keep remembering, adding, subtracting's last.
Is it times 10 or divided by?
Don't you try that with me again. I think I'm right this time.
Okay.
You guys, that's a dot.
Okay.
Unless my eyes are really bad.
That's a dot.
That's a dot. All right. You guys are playing with me. Now you're going to ask me that all the time, huh? It's the plus signs that fool me. Or the divide that look like plus. How y'all doing? You getting it? What's the answer?
Fine.
Was it 5? Okay. I don't know, I can't tell. 5, so 5? Sounds like a couple people got 5. Yeah, it looks like 5 to me. Yeah, 5. All right, where do we start? Yeah, in here, in the parentheses, but we do the 36 first. Down here, we do the 25, 5 squared is 25, 3 squared is 9. Do the powers, right? Do all the powers. Good, like that. And next, come down here. We're going to go parentheses was at minus 25. And down below, 4 times 25 is 100 minus 90. And that's what? Minus 50 over 10. Good to there? Is that making sense? You guys see how I'm doing that? Yeah, so now the absolute value makes it positive, cancels that out. The bottom one has no sign, so it just leaves it alone and vanishes. The absolute values leave after they do their job, or in the bottom, do nothing, then leave. They just make sure it's positive in the end, then they leave, right? And 50 over 10 is 5. It's not too bad, right? It's easy to make a small mistake, though. Just takes practice. Questions on that one? Let's see. All right, so look at that. Let me write it a little bigger here. Minus 2, minus 8, minus bracket 2, minus 7, plus 9 squared all over. Minus 4 squared times 3, minus 5. Okay. So try that one. So adding, subtracting is last. Keep that as your mantra. I don't know why it's warm in here. It doesn't feel like they have the AC on and all, huh? It's all right, it works out perfect. I usually ask them to turn up the heat on test day. I'm kidding.
You're faster and get out of it.
We got an answer?
Is it 51 over 43?
I don't know. I can't tell.
That's what
Is what you got? Oh, sounds promising. So I guess it just stops there, huh? It's not a clean. No, it doesn't divide. All right. So I'm gonna multiply these guys. Positive 16, right? 2 negatives make positive. And this would be minus 14 and 81 over 16 times 3 minus 5.
Is that not negative 16?
It's positive. Yeah, good question. Everybody see that it's positive 16 there? Let me rewrite it a little neater. Yeah, why is that positive 16? Because that negative is in the game. Right? It's on the field in the game. 2 negatives, positive. 16, regular 16. Good to there? Now, where do we go from here? This will be, finish these brackets. What? Can you help me with that one? What is that? 81 minus 14. What is it?
67.
67. Yeah. Over, this will be 48. 3 times 16 is 48 minus 5. And so then that's minus 51 over 43. Yeah. Yeah. That looks right. Is that good?
But we won't have one on the test.
The second test, but not today.
Second test. This one's a little tough.
Yeah.
And I didn't keep the brackets. And then you need to keep the brackets, turn them over,
Yeah, right.
and work those.
Right.
It doesn't matter though, does it?
You got to finish the brackets. Parentheses and brackets are the same thing basically. They just,
Yeah.
which means you always finish parentheses and brackets.
But it wouldn't matter because it's all subtraction and addition, right? Does it matter if you add the 16 and the 14, then the last one, what was it?
Yeah, no, you got to finish the bracket. It doesn't matter.
Okay.
Yeah, it's like a parenthesis. You always got to do what's in the. Please excuse me, dear, I'll tell you. Parentheses is first. Brackets are parentheses, effectively.
Okay.
Brackets are the same as parentheses. They must be done first. They are priority.
I was gonna ask you, I've always heard the bed mass.
The-
version. Bed mass, brackets, exponents, division, multiply.
Oh, I've never heard of that before. So it's the same thing. Brackets and parentheses are functionally identical. They're just stylistically different. Yeah. Yeah. So either way you want to say it, the parentheses brackets are always first. Yeah. Functionally identical. There is no difference. Same thing with curly brackets. Sometimes they'll give you curly brackets. It's fancy parentheses.
If you have parentheses inside of a bracket, you still have to work those.
Yeah, inner layers to outer. That's right. That's right. Well, you guys are probably tired of doing these problems. Let's stop there.